Then click on go live. Yes. I hope that all of you have joined. I'm going to start the class. Okay. Everyone is ready? Okay. Yes, it's live streaming. It's working. So finish and just put it down and yeah. Okay, how is everyone? How many have joined? I'm waiting for all of you to join, students. Okay. I've started the class. Hello everyone. How everything is going on? Welcome to today's class. Okay. So good afternoon and welcome to today's class. Good afternoon and welcome to today's class. I hope I'm audible. You know? So let me click here where it is. This. Okay, students, so let us start our class. You know? No need of wasting the time. I can wait one more minute for the students to join. Then I have to start. Okay. So I'm just going to check on the YouTube what is happening there. Hello, students. Okay, so one of the GNB have joined. Okay, so Sheila have like joined, maybe an individual student maybe have joined. Okay, so welcome to today's class. Let me show this video on the spotlight and here we go. Boom, boom, spotlight for everyone later. And this, like this. So I hope that I'm audible and the video is available on your screens and PPT slides are properly visible there, right?
Vanti fellow screen.
Who's this? Like anybody?
ఏదైనా ఉందా లెసన్ ఫిజిక్స్ లో దాని మీద ఉంది మీరు చూస్తారా ఓపెన్ చేసుకోండి నా ఇప్పుడే స్టార్ట్ అయింది.
Students, please mute yourself. Okay, students, so soon I'm going to start the class, okay? So please text yes or no if you're ready for the class to start, or if there is any issue, you can text in the chat box. And now, students, if there is any issue, you can text in the chat box. See, so these are the topics. First, we'll go through the lens. Okay, first we'll go through the lens. Then prism. This is first lens. Okay. I mean, in the yesterday class, what we did, we have gone through the lens already. So today we'll progress further fast. Okay. So we have seen some part of the prism in this Hyderabad batch. We have seen some part of the prism in this Hyderabad batch. So we'll continue today's class from that only, but we'll do a little bit of the recall, revision. Fine. We'll do a little bit of the recall or revision. Then we'll see the optical instruments. Okay. After this, we'll solve the numericals. Okay. And this will be the end of today's class with the completion of the chapters. Okay. So we are having now 50 minutes remaining with us, like approximately 45. Okay. 50 to 45 minutes with us. so that we can complete this thing. So are all of you ready? Get set, go. So see what we studied in the previous class. If you focus here. Okay, you want me to close this? Refraction through thin lenses. We studied about the lens. We studied the definition of the lens. And then what? We studied about the lens. We have studied the definition of the lens. Okay. That what basically is lenses. We have studied the type of lenses. Then we studied principal axis, wave same like for concave and convex mirror. Then we studied some important points. Also, we have seen a formula for the focal length. This gives you the focal length of what? Lens. Then we concluded that this was the formula and this is what? If you substitute minus in the plus, this will give you the mirror formula. And this is for the lens formula. Then we studied, yeah, these are two symbols. This is given for the diverging lens and this is given for the converging lens. But there is some conditions are given. Suppose object is on the first focus on the left hand side, you will get a parallel rays on the other side. If the parallel rays on the left hand side, you will get the you will see that the rays will come and merge to the focus. Okay, so these are different cases. After this focal length, we need to find it out. So how will find the focal length? So it was given like this: 1 by f mu l mu s minus 1 upon r1 minus 1 upon r2. This gives you the focal length. Okay, so for biconvex lens, focal length is given as, I told you this thing. I mean, if the see, okay, let us see on the next slide. Here you are able to see properly. If the focus is positive, it's converging. If it's negative, it's diverging. We have seen this thing. So these are annotated slides. All the things are completed. So now let us start with the prism again. Okay. So I'm going to start with the prism again in front of you. Okay. Prism and natural phenomena due to sunlight. Now let us see this. Okay. Prism and natural phenomena due to sunlight. So in this, what the condition is? See, first we'll go through this topic. Refraction from prism. Again today, somewhat revision. Then dispersion will start, then rainbow formation and scattering of light. Okay? Got it? Yes? Okay. So refraction through the prism is this. Suppose the white light is entering on one side of the face. Okay? And it passes from inside this prism. See, I told you prism is what? If you see, what was the prism? I explained you this thing, no? See, I told this thing. If you take two glass plates, arrange them in this such a triangular pattern. If you take a glass slab, by the way, rays coming and it is going like this. Okay. But if you take a triangular prism like this, here you can see this. If it's perpendicular, it will pass perpendicular. If it's with some angle, it will do what? It will do a lateral shifting. Okay. And this lateral shifting will be like this. It will be some distance. Okay. And if it's a prism, ray will enter like this from one side. And after passing inside this prism, it will show dispersion into 7 colors. Okay, students. So this is a refraction through the prism. Now let us go in the depths of this topic. So, okay, you have joined now. Jinvil Lipakshi students have joined. Okay. So welcome to today's class, all of you students. I have just started prism here. I hope it's visible to you. So how are you, Jinvil Lipakshi students? Everything is fine. I'm audible properly. I'm asking these things because you have joined now only. Okay. I'm audible. Yes or no? Wait, let us see. Maybe other students may be joining. Okay, very good. Excellent. So be focused here. What I just told is this. I just started a prism. You can see this. I'm not lying here. Okay. See this reflection from the prism, dispersion, rainbow formation, scattering of light. So I've started prism. In this, if a white light is entering like this, okay. So after it passes through this prism inside, it will disperse into 7 colors. This is only the condition for the white light. Okay. Unlike this slab where the ray, if you take a slab like this, okay, this is normal. If the ray is incident like this, okay, it will do like this. It will make an angle like this. It will come like this. Right? So there is a shifting. This distance, shifted distance, is known as lateral shift. The shifted distance is known as lateral shift. Okay. Refraction through prism. Now let us see this. Okay. See students, now we'll be seeing refraction through prism. Prism se dekhenge, okay. What is this angle of deviation? Now let us first see this. Now we'll see first what is angle of deviation. So let us take a prism. So I'm taking prism in front of you. See this carefully. This is the prism. Triangular prism, which is on your screens in the sky blue color. Okay. Fine. See, suppose this angle is what, by the way? This angle is angle of prism. Okay. Suppose the ray is entering like this. This is what? Incident ray. This is incident ray. Okay. If it's entering like this, okay. So you know this thing, this is what? This is normal to this surface. Fine. Now when the ray will pass from a rarer medium, which is having refractive index 1 to a denser, suppose this is internal material is made up of glass. Internal material is made up of glass. And this glass is having refractive index as mu equals to 1.3, no, it's 5. 3 kiska hota? It's 3 is of water, okay. So here you can see this, when the light ray, which is shown here with the yellow color, it is entering from a rarer, which is an air medium, into a denser medium, that is glass. So it shows this kind of turn. Why it is? Because if this is normal, okay, and if this is angle of incidence, R1 is this. So we can say here, when the light ray passes from a rarer medium to a denser medium, it bends towards the normal. So that's why you can see that this yellow light is burned. It's sorry, not burned. Yellow light is turned with some angle as compared to its incident direction. Okay. And we say here angle of incidence, of sure it's greater than R1. And why? Because it is due to the process of refraction following the Snell's law. N1 sin I, N2 sin R. It is following what? It is following the Snell's law. Okay. So when the ray of light passes from inside, then it comes outside like this. Okay. So you can see this, it is entering here, then it passes here. Now you see here, normal is which? Let me erase some of the parts to see it clearly here. Okay. So you can focus clearly here. Now students, if you see, for this yellow light now, the normal is this white light. Okay. So this R2 is basically the angle of incidence now. Okay. So now this yellow light is going from a rarer, not a rarer, but now it's a denser medium. So now this yellow light, when it is showing a reflection on this surface, second surface, So it is passing from a denser medium to a outside medium, which is a rarer medium. Okay. So now it is passing from a denser medium to a rarer medium. And this I is basically here equals to R2. And we know this thing, when a light passes from a denser to a rarer medium, it bends away from the normal. That's why this angle, which is basically the angle of refraction now for outside, it is basically named as emergent ray, and angle is known as emergence angle. Okay. And now we can comment this, that R2 is less than E, or E is greater than R2. Why? Because this is in the rarer medium. Okay. So these are the conditions. First, text up to this. Are all these things clear to you? Put a text in the chat box first. Students, is this thing clear to you? Put a text in the chat box so that we can proceed towards derivation found. What is this angle of deviation, I mean? Okay. Clear? Okay, I hope it's clear. Okay. So these all things are clear. Now we'll see what is basically the angle of deviation. So in this, if you focus carefully, so this angle is the angle of deviation. So I will write here, del is basically the angle of deviation. So I can write the definition in a very simple manner, that the angle by which incident ray has turned from its initial direction, incident ray has turned from initial direction, or angle which emergent ray makes with
The other link is there.
angle with the emergent ray makes with what? Incident direction.
Chrome. Other link. Okay. 4 to.
Students, please mute yourself. Okay, good. So welcome to today's class, JNV Chitradurga students. We are on the prism. I will try to end the class today, complete this ray optics, and from next session we'll start the wave optics. Okay. Okay, this we have studied in the previous class also, but we want the main derivation. So I'll say here, see, these are some symmetric triangles they are taking, but it's not required for us. I'll say like this, that final result you have to remember. See, this is to be remembered. This is a star point here. Okay. So we can say angle of deviation is what? Angle of deviation is equals to incident angle. See it carefully. What is the angle of deviation? Angle of deviation is incident angle, okay, plus emergent angle minus angle of prism. Incident angle, emergent angle minus angle of prism. Okay, remember this always definition. Fine. And how you can derive it, it will be given on your PDF. There are some geometrical laws you can see. If anybody is interested in the derivation, you can just see the laws. Okay. So I will get like this. If some prism is given and the ray is entering like this, so from the initial direction, it will come outside like this. So the angle which it is making with the initial direction, basically this angle is the angle of deviation. Okay, and it's given here like this, I plus E minus A. Okay, where A is known as angle of prism, I is the angle of incidence, okay, E is what? Angle of emergence. ठीक है, this is deviation angle. समझ में आ गया? Got it? So angle of deviation formula is what, students? If we see, suppose this is a prism, apex angle is this. ठीक है? This is a prism. Okay. This is apex angle. Somewhere you'll find it as what angle? Apex or angle of prism. Okay. Angle A is what? Angle of prism. Okay. If the incident ray is passing like this, so I will say incident direction is this, emergence direction is this. So this angle is the angle of deviation. Okay. Now there is, this topic shows you the variation, how the angle of variation varies with the angle of incidence. So you can say like this, if we focus on this graph, students, okay. So mark 2 points, say point number 1 and the second point, the point number 2. So if you can see the abscissa and ordinates here, okay. I mean on the x-axis, it is this angle, and on the x-axis here, it's this angle. So I will say there are two x1 and x2 coordinates for which there is only single y coordinate. Do you agree this or not? Students, do you agree with me at this point? Okay, yeah, it's true. And now we can focus this. So just let me highlight. So for this y coordinate, that is 50 degree, we are having two x1, x2. I mean, one angle is this between 20 and 40 degree, and other angle for the same 50 degree, according to the graph, it is between 60 and 80 degree. So I can conclude like this here, that I'll conclude here or yes. See, so I'll conclude like this. I'm writing. See here, focus here carefully. I will say that for two angles of prism, I mean, for the true angle of incidence, for two angles of incidence, there is only one angle of deviation here. One angle of deviation. So this case is also possible if we take the case of prism. Dekho, why are you studying prism? You know, basically dispersion phenomenon is the main thing here, right? If you analyze all the physics of the prism, no. Prism is well known for the dispersion only, you know, because it's a beautiful optical phenomenon. Next thing is this. We have seen a glass slab. Glass slab means there is not a lot of turning there, okay, but in prism it is. Okay. Okay. So from here, actually, we ended at the last class. In the last class, we ended actually here. Fine. Okay. Now let us proceed towards the next. So we have founded this thing. Reverse will be also true. Now let us see minimum angle of deviation. What is it? What is this known as minimum angle of deviation? See, minimum angle of deviation is like this. It means del must be minimum. So what are the conditions we can put in this derivation such that the del is minimum? Okay, it can only happen. See, initially we have seen the prism. Prism was like this. Okay, and if the ray is passing like this, if the ray is passing like this from the prism, it is bending like this, and then it is bending somewhat like this. Okay, so there are two bends. First is where when it passes from the first surface, incident on the first surface, rarer to denser, then inside it's bending. Then again it is bending when it passes from the denser to the rarer medium. So two bendings are there. Two bendings are there. Right? That is the case of deviation. Fine. But now they're asking us, what is the condition of this delta to be minimum? This can only occur. They say that if this inside ray, which is basically when the ray incident ray, I mean the incident ray when is passing from the rarer to the denser medium after refracting through this first surface, it becomes parallel to the base. So when this, I'll be mark the point, say M point is given here, and this is N point. So I will say when Mn ray is basically parallel to this, say this is A, B, C. Let us write like this, okay, for convenience, sake of convenience. So we'll say MN is parallel to BC. Okay. So when this condition, this is a base. You can write here base or base. You can write anything. Okay. So when this is the condition here, I'll say the angle of deviation value you will get as minimum. Here they already took this thing equals to dm, which symbolizes, it's just a symbol. You can use anything, km, pm, but dm it's like official things. So dm will say it's a minimum angle of deviation. You know, here they have also took one more condition that I must be equals to e. Of sure it is. If the ray is going like this from the prism, if it's parallel, there's a lot of chances that emergent ray will be also having the same angle. And experimentally it's found. So we'll say for this holds the true condition. This condition is true. Okay. And also by symmetry, we'll say like this. If this angle is same, this angle is same, it's sure no, R1 and R2 will be same again. Corresponding angles, no? Okay, I mean they're in the same triangle. This, if you see, these are alternate angles, this will be same and this will be same. So we'll put the value here. R1 and R2 will also be same. Let us take some generalized value R. And we already know the deviation formula. It is given by this. This is what deviation formula. देखा ना पिछले formula में. We've seen the angle of deviation actually was what? Angle of incidence, angle of emergence. See here I'm not using this. Okay, but you must understand it. It's same. Minus angle of prism, or like this for you. And now you have to apply the conditions. Put I equals to E. So when you will put I equals to E, angle of deviation will come out to be equals to dm, which we already took. This is twice of I minus angle of prism. Okay. Here we'll get angle of prism is equals to this. A plus dm by 2. So from this point we get what? Angle of prism. No, sorry. From this point we get such an angle of incidence for which the angle of deviation is minimum. Okay. See, this is what angle of deviation, minimum angle of deviation. This is the condition which we got after some substitutions. Okay. So I'll say if someone is asking from you, what must be the angle of incidence such that angle of deviation is minimum. So you can solve this and simplify it. dm plus a angle of prism by 2 will give you I angle. That is the angle of incidence for which the condition of minimum deviation will be followed. Okay. Fine. Now we know one more thing, that A is equals to R1 plus R2. See this triangle. If you focus on this triangle, see, internal angle of the triangle is property is what? Internal angle of the triangle is the sum of the external two opposite angles. So these are the two opposite angles. होता है ना इसमें? A angle is equals to what? Sum of these two angles, opposite angle of the triangles, है ना? So we'll say this is equals to, these are the properties we studied in 9th. I mean, on Adi Sharma, you get a lot of properties. Okay. So from this, we'll get A equals to 2R because we already assumed R1 equals to R2 equals to R. Okay. Yeah. So, Jane Viranga ready students have joined. Welcome. Cool. So from this, I'll substitute one more thing. Let us substitute this A value is equals to 2R here. Okay. It's up to you. So we'll do some substitutions and apply the Snell's law. We know this thing. For both of the surfaces, Snell's law is available here. This is suppose glass. Suppose this is air, this is glass. Again, this is glass, then air. So rarer to denser, denser to rarer. Applying it, ultimately you'll get this answer, students. Okay. That is minimum angle of deviation. Somewhere you'll find mu symbol. It means the same, refractive index. Okay. Derivation, I've given you a little bit of the overview. Main thing is what? The formula here. Because applications, IIT JEE, nobody's asking you the subjective thing. Theory likho. No. You must know a little bit. You must know. If you forget, you must have that ability to make the formula again. So you must know this thing. What is the formula? Why this formula is applied? How it is founded? Application. In which concepts it can be applied? This all comes via practice and in-depth understanding. Okay. So we'll say here, this mu minus 1 into angle of prism, this will give you the angle of deviation, which is given by this. This is the minimum angle of deviation here. Okay. Remember this formula. Okay, students, so this is a concept test for you. This is a concept test for you. Answer this. You are allotted few minutes for this to answer. Okay. Here they're asking from you minimum angle of deviation. You know the formula. Minimum for this condition to be minimum, it can be used by this symbol. And minimum angle of deviation is given by a glass का refractive index -1 into angle of prism. Okay. And this is known as minimum angle of deviation. ठीक है. Mu is what? N21 means refractive index of the second medium with respect to first. Second here is glass. First is the surrounding medium, that is air or vacuum. We'll use 1 always for this. Okay. इसके लिए 1 is a value. इसके लिए 1.5. 3/2, no? Fine. And the angle of prism is given 4 degrees. So students, find the answer. I'm waiting for your solutions. Sorry, I'm waiting for your answer key. Answers. Text with chat. Put a text in the chat box. Simple. What do you think? What will be the minimum angle of deviation? Everything is, the question is already solved. The general format is given to you. Put the values and you'll get the answer. Students, put the value and you'll get the answer. Any one of you. See, you, since this is your question, no, you might answer it. What's the problem? Okay, I'm solving for you. See, they're asking find the minimum angle of deviation. So the answer is this. Minimum angle of deviation, I know by the formula is given by this dm. Okay. And this is what actually. This is equals to refractive index N21. It means this is 3/2. -1 into angle of prism is 4 degree. So through this, I'll get the answer as 1/2 into 4 degree. Okay. This gives me 2 degree is the answer. So minimum angle of deviation. So I can draw the figure also if you want. If the ray is entering like this, normal is like this. It will go parallel and it will then come out like this. Okay. This incident, this is emergent. Okay. So I will say here, angle of deviation will be this angle, which is minimum, which is equals to 2 degree. Okay. I hope this thing is clear to you properly. So I will say here, students, angle of deviation is basically this angle del minimum 2 degree. Okay, this E is for this emergent ray. Fine. Is it clear? See, if you are not giving the text in the chat box, I am assuming it's clear. Okay. Solution is same here. Now let us proceed towards this question. This was actually the solution of that saying. Okay, so let us proceed towards the dispersion of light. So dispersion. Now write the heading dispersion, students. Now we are on the next of the topics. Okay, so it's good. This will be completed. Dispersion kya hai? From the lower classes we are studying this thing. Dispersion is nothing but dispersion is what? Dispersion is like if the white light is, you know, it's breaked into its constitute colors. If you are able to see that thing, break matlab you are able to see in the white light that white light is nothing but the combination of 7 colors, and this is shown by the prisms basically. Okay, so this is known as dispersion. Remember always, this is known as what? Dispersion. Okay, so we say like this. See here. Spreading of white light into the full spectrum of wavelengths. Full spectrum, when it says spectrum, it doesn't mean all that electromagnetic spectrum starting from the radio to the gamma X-rays. No, it means just that visible part of the electromagnetic spectrum. It's full wavelengths. Okay, so here this which you are able to see on your screens, you are able to see on your screen, students, this is nothing but visible region. This is nothing but the visible region. Okay, it starts from 400 nanometers and it is ending at 700 nanometers. This is violet. This is red here. Okay, starting from the violet and it's ending at red. Is it clear? Okay, now let us move towards the next thing, that is dispersion. Okay, now we have seen dispersion, how it looks. I mean, splitting of that light, white light into 7 constitute colors. But how it works, let us see the mathematical equations now. See, don't go in the derivation of this, just remember these equations, okay? Mathematical equations. So remember one thing, that refractive index is inversely proportional to lambda square. This is for dispersion. Remember this, okay? Always. Cauchy's equation. See, if you see Cauchy's equation, somewhere you'll find it like it's progressing like this lambda cube. So somehow from there it's derived. Okay, remember it. So its refractive index is directly proportional to 1 upon lambda square, or it's inversely proportional to what? Lambda square. Okay, clear? Now see, you can see here properly ki if the light, this is what kind of light source, okay, and the blue light, violet light is coming outside of it, and the prism is kept in front of this violet light, okay. You can see how this incident ray, this is what incident ray, it turns here, you know why? Because it's passing from a rarer medium to a denser medium, and when again it's passing from a denser medium to a rarer medium, how it is deviating, you have seen this thing, okay. So see, if I'm using a red light, suppose if there is a red light, so what's going to happen? See, we know this thing according to this relation, lambda of the red is greater than violet. If you see this pattern, this is blue, violet. Okay, violet is having 400. Red will be having a more, sure. Anna? If this is the condition, if I match with this will give me violet ka refractive index is more than the red. So if you apply this minimum angle deviation condition, see, because you can see this thing, this is parallel to the base. This ray inside is parallel to the base. Parallel matlab the angle will be minimum here. This angle of deviation will be minimum here. Okay, students, clear hai? Easy, very easy, don't worry, okay. So I'll say, if I apply this minimum angle deviation condition here, okay, then what's going to happen? So we already know this thing, dm, see here carefully. We already know this thing here, that refractive index of violet is greater than red, because due to this relation. So when you apply this here, so I will get dm for minimum deviation for the violet is greater than dm minimum deviation for the red. Remember this, okay. And on the next slide, if you see, okay, I'm launching this video, okay, watch it carefully. So I'm launching this video in front of you, watch, just focus here carefully. I'm erasing the rest of the things from this. Please be focused. See what is happening. If I change this lambda from 400 to the red color, or maybe say green, yellow, you can see how this emergent ray is turning. It's deviating, no? Okay. So you can see, if I show you some other, white light pattern, so it will disperse into 7 colors. Let us see it again. So see here carefully what is happening. As I'm increasing the lambda from violet to red color, with respect to each wavelength connected with a particular color, the angle of deviation is changing. And we know that lambda of a particular wavelength of a light of particular color is connected with the refractive index with this formula, which is on your screen. This n is inversely proportional to lambda square. So ultimately, we can conclude like this, that with this mathematical equation, we are getting like this, deviation, minimum angle of deviation for the violet comes out to be greater than the minimum angle of deviation for the red. Okay. And from this video also, I mean, this last picture, you can see this red angle. Okay. This is incident ray direction. And if I show you this red angle, I mean, this red length, This is minimum angle of deviation for red color light. Okay. And if you want to find for the violet, which color? Violet. Okay. Let us take this dark blue. If I am extending it back, so I'm getting the minimum angle of deviation like this. So from here we can also conclude. I mean, this is an experimental conclusion. Okay. This is what an experimental conclusion. And the previous was mathematical. So these both are in synchronization. Okay. They're in sync with each other. They're same. Okay. So this proves our result here. So we'll say delta of indigo or dark blue kind of. Okay. It's greater than the delta of red from this picture also. We can observe this thing. Same, the result we are getting from this mathematical equation, which is having the fundamental hidden in this refractive index inversely proportional to lambda square or directly proportional to 1 upon lambda square. Is this thing clear? Is this thing clear, students? Okay. Let us move towards the next. Okay, let us see some natural phenomena which are shown by the sunlight. Okay. Okay, I'm going to launch this video. Just focus here carefully. See what is happening here. See, as the rainbow is in front of the sun. Okay, so this is the complete video. Just watch here carefully. Then I'll explain you. Okay, I'm launching it again. Okay. So as the sun is moving back, okay, or your back is to the sun, you are able to see the rainbow in the rainy season. Okay. What is happening? You know, the water droplets in the sky, these all small water droplets are behaving like a triangular prism. Okay. So when the sunlight is passing via these small water droplets, since these small water droplets are behaving like a triangular prism, it will show each of individual small water droplets will show dispersion. Okay, so due to this, we are able to see the 7 colors. Okay, and we see the rainbow. Okay, is it clear? So it's very simple. See, as your back is to the sun, you're able to see the rainbow. The reason the water droplets in the sky are what? Prism. And if the sunlight is coming white light, it's a combination of 7 colors. And each of these water droplets disperses this sunlight, white light into 7 colors. And you're able to see a pattern which is like a rainbow color, like seven colored rainbow. Okay? Okay? Yeah. So now let us see the next phenomenon, scattering of light. See, suppose some incident light, it strikes some dust particle. So what happens? You may find this. We'll also name it as in the next slide as Tyndall effect. Okay. So what is happening when this incident light strikes some dust particles in the atmosphere, or you can find this thing in the room also. So it scatters. I mean, its path is changing into several different directions. Okay. So the definition is this: when a sunlight, just be focused, when sunlight or the light simply wave passes through an imperfect medium. Imperfect means via some dust kind of thing. I mean, which the refractive index is not fixed, it's variable. Then it gets deflected off of its straight path and scatters in many directions. And this is shown here. Okay. So you can see, if someone is asking from you that why this blue color of this water has been reflected on the sky. So how you'll say, you can say this is what? The scattering of light. This is nothing but the scattering of light here. Okay. So you can consider like this, because the light consists of 7 colors violet. Okay. Okay, now we'll understand which color is scattering the maximum light and which color is scattering the minimum light. So remember, for a diameter of a particle, which is having its diameter is as what? Less than the lambda of a particular wavelength. Okay. Rayleigh scattering is defined as 1 by lambda 4. So it says like this: if you consider the pattern of the part of the electromagnetic spectra that is visible region starting from violet, which is 400 nanometer lambda, having the wavelength as 400 nanometer, and ending at this red, which is having the lambda as 700 nanometers. Okay. So according to this Rayleigh scattering formula, you can say like this: the violet scatters the most and the red scatters the least. The reason, because scattering is given here inversely proportional to lambda raised to power 4, or directly proportional to 1 upon lambda raised to power 4. It means if just a little bit we increase the lambda, there will be a big amount of decrement in the scattering, or if you just little bit decrease the lambda, there will be a huge increment in the scattering. Okay, so I will say like this: we know this, that violet is having a very less wavelength, 400 nanometers. So less wavelength matlab bahut zyada scattering. Okay, violet is having the a very I mean it's the longest wavelength, so it's 700 nanometer. So if it's lambda is more, scattering will be least. So it's shown here already. Okay, so that's why the violet light, I mean it's scattered the most, the blue color is scattered the most. That's why you're able to see that this picture on your screen. Okay, this scenery. So now you can explain someone why you're able to see this kind of color, the water and the sky, what is happening. So you can see it's due to the scattering of the light by the dust particles in the atmosphere. Not only the dust particles, somewhere it will be some water droplets, some dust particles, some other particles, you know, fog, smoke, and many particles are there. And now, yeah, this is also very good scenery, the sunset. Why, you know, when you see this sunrise somewhere, the most you know, perfectly precisely, if I say during the sunset, you will see this red color around the sun. What's the reason? We call it as, okay, so I'll show you. Suppose this is an observer. We are observers standing on the earth like this. Let me make the diagram. This is me or anyone, okay. Sun is on the top. See, when the sun is nearly overhead, the sun rays which is coming towards you is shown by this green arrow. Okay. And this is observer and this is the atmosphere. This is the earth. This periphery's boundaries is of the earth. This periphery boundary is of the atmosphere. And there is a gap in between. Okay. And remember, between the earth surface, earth platform and the atmosphere, there are layers of different refractive indices or indexes. Okay, there are the layers of different refractive indices. These are not fixed. I mean, this all complete atmosphere is not only of the same refractive index. You can say like this. Okay, so when the sunlight is reaching, okay, distance of the atmosphere through which the sunlight travels in the atmosphere is this much given here. And when the sun is on the origin, if you see now, see this. Now the distance is this. So sunlight need a less distance to travel via the atmosphere when it is overhead, and sunlight need more distance. This is shown by this maroon arrow, red arrow, okay, that it needs a more distance to travel via the atmosphere to reach to our eyes. Okay, and when it needs more distance, what happens when it's at the origin? This red color is scattered and it enters into our eyes, and that's why we're able to see the sunset view nearby like reddish color or orangish color. Okay, so students, that was all about the prism. And in the next class, okay, let me give you a little bit of the overview of the next class. In the next class, we'll see optical instruments. Okay, just put a text in the chat box. Any doubts? Are you having any doubts? Okay, so in the next class, what we're going to study is this. We'll go through optical instruments. We'll see the image formation due to microscope. We'll see magnification of the microscopes. We'll see astronomical telescope image formation, and then magnification by astronomical telescope. These four things we need to see in the next class. Okay. So some pictures I'm showing you here. This will be your next class PDF. So this you can see. I'll put the notes on the link. Okay. So from that you can read it and come in the class. So it will be easy for us. Okay. So in the next class we'll be starting the wave optics. Okay. In the next class we'll be starting what? Wave optics. So in the next class, in like the beginning 25 minutes, we'll complete this, and the remaining minutes will start the chapter that is wave optics. Okay, so we'll study with the microscope, And then we'll study the two type of microscopes are what? These are basically simple microscopes and the compound microscopes. Simple is just simple. We were having this microscope when we were in the childhood days. We were in the geometry box. We used to burn the papers, है ना? Or the leaves, dry leaves. And compound is this, find in the biolab. Then we'll understand this, that what is inside phenomenon going in the simple microscope, that there is one lens only used in the simple microscope. And for the compound, you will be able to understand that for the compound, we'll also understand this, what is this definition of the near point. Then we'll see about the compound microscope, that is, we'll see the derivations, formulas, all of. Okay. So we'll see about in the compound microscope that inside the compound microscope, if it is having the L length tube, two different converging lenses, biconvex lenses are used, having a different apertures. Okay, one is having a more diameter than the other one, and they are both placed parallel to each other. Okay, and when one of the object is kept like this, you are able to see a magnified image. This all things will be explained in the next class, not now. Okay. So after this, after all these derivations, we'll start with the astronomical. We'll also solve the numericals. Then we'll start with the astronomical telescope. Okay. I'm showing you here this way. Yeah. So this is a very cool picture in front of you. Stars are there. So we'll understand. Okay. Yes. Okay. We'll understand how the astronomical telescope works. See, microscope is for what? To see the micro things. Okay. Microscopic things. As the telescope is for what? If the things are far away, heavenly particles and all these things, bodies, we are able to observe them external view via what? Astronomical telescope. So we'll see this and we'll understand that in the astronomical telescope also two lenses are used, but the places are interchanged. The one which is having the more diameter aperture is placed first now, and the next will be placed behind it. Okay. So the same procedure will be followed. We'll derive some derivations, ray diagrams, and some formulas, magnification, and all these things. Then at the last, we'll do some numericals based on this. Okay. Yes, finish. So that was all about today's class, students. Thank you so much for participation. In the next class, we'll meet with new concepts and strategies to solve numericals. Also, we'll try to start a new chapter, wave optics. Okay, is it clear? Fine. So now you can leave the class. If you're having any doubts, you can put a text in the chat box. If you're facing any doubts, you can put a text in the chat box. I'm available here. So I'll end the class in 4 or 5 minutes. Okay. So if you're having any doubt, you can put a text in the chat box.
As she's telling you put that salt in here, from that sense she's telling me, ma'am, and she told me, if go and call the ma'am. She's telling me. No, and she's telling her at dinner, I will also put salt in your hair. She will take revenge. Ma'am, she will take revenge on me at night. She came with a bowl of salt. Ma'am, I did not pour. Ma'am, I am putting mother from the soap. Ma'am, she can't go, ma'am.